Hi, welcome to Manufacturing Pathways Core 1. This is our final module, and in this session we're going to go through a little bit of close molding, demolding, and trimming. So we've kind of gone through the whole part production now in our first class. Core 2 and Core 3 are going to go into a lot more detail, so we hope you enjoyed Core 1. All right, so when we start thinking about close molding, it is the difference from that from open molding is now we're working in a tool that all of the surface is covered by a tool surface. Open molding had a tool on one side typically, and the other side was exposed to air. You know, that has a definition with the Environmental Protection Agency also. Closed molds could be match tools, so there's tools on all surfaces. A closed mold can also be done by placing a vacuum bag over the laminate, and that would be considered closed molding. Okay, so the difference from open to closed is now that the part has tool surfaces all the way around it, whether it's a bag, a call plate, or a rigid tool. And now we talk about how do we use that. And so as you look at closed molding, it opens up different opportunities. So in open molding, we're here at atmospheric pressure. Once we move to closed molding, we can start using vacuum to do work for us, and we can inject the resin and it can do work with us. So in the really high volume composites that you might see in an industrial application, you would see something called resin transfer molding. And in a resin transfer molding process, you would have rigid tools, like let's say it was a door, it'd be a top and bottom tool. All the reinforcing materials, core materials, and everything else is in that tool. It's clamped shut, and then resin is pumped under pressure into the tool, and the tool has vent holes that's going to let the air out. Okay, so that's resin transfer molding, pure pressure, no vacuum applied. So that's one extreme. Let's go all the way over here to the other extreme is the resin infusion process. And we've hinted on this a little bit. In the infusion process, now we're typically using a vacuum bag. So now we're going to take all of our reinforcing materials and cores. We can lay those into a rigid tool, can be our open mold type tool, but instead of laminating it with resin and hand operations, we're going to put a vacuum bag over it, and we're going to pull a vacuum on that, and we're going to suck the resin in. And what this does is it consolidates the laminate, gives us a higher fiber to resin ratio, and can give us better properties. It also is very good at process control, because if we run to the same vacuum pressure all the time with the same laminate schedule, we get a much more consistent output than we would with hand layup. So infusion, pure vacuum, no pressure. RTM, pure pressure, no vacuum. Okay. In the middle, we call that VARDM, vacuum assisted resin transfer molding. And so all that means is I'm putting some vacuum on it and I'm pressing on the resin with pressure. So it's important to know that a part does not have to live in one state during the whole molding process. So you often, especially in VARDM, will be adjusting the injection pressure and the vacuum level during the production of the part. So at some points you may be closer to infusion in the process, and at other points you may be closer to RTM. So you might start out with a very high vacuum and a low pressure, and transition as the part gets full. You need more pressure to push the resin, you might be upping the pressure on the part, transitioning closer to an RTM process. So there are a few other related closed mold processes, and a close cousin would be wet bagging or compression molding. And in this case, all of the laminates are rolled out just like you would in the hand lay process, and we're going to put a force on it, be that in a press, or if we put a vacuum bag over it and apply vacuum, we do vacuum compression. Okay, so those are the kind of basic processes. We'll show you a little more here. And there are hybrids between them. There are no really hard and fast rules here. There's a lot of frontier where things can be created. And you can combine these processes together to make a part, and it can work. All right, so this is the traditional vacuum bagging process. And if you were wet bagging a laminate, you would have first your mold, you'd have your wet laminate, which was saturated. You would put a layer of peel ply. Peel ply is a fabric material with a coating on it that the resin's not going to stick to, but it's a porous fabric and it's going to let the resin come through that fabric. Okay, that's going to come through the fabric, and there's an optional release film that could come through there, which would have holes in it, and it's going to go into this bleeder layer. And the bleeder layer is nothing more than an absorbent material that's going to suck up that excess resin as it comes up through the laminate. And then we have our bag, of course. The bag is sealed around the perimeter, right, with a special tacky tape material. It's like a putty tape, it really is. And then you pull a vacuum on the part and you compress the laminate. It's that simple. Okay. Infusion is the next step up. Okay, so much like the vacuum bagging process, we put the laminate, cores, everything under a vacuum bag, but we don't have resin in there yet. So we're going to basically develop a arterial system that's going to distribute the resin. There's going to be a series of resin runners that you're going to see in these pictures that are going to let the resin flow in directions. And we're going to pull a vacuum on the bag, consolidate the laminate, and then we're going to introduce the resin into that vacuum environment, and it's going to run through these runners and it's going to saturate the laminate. And that's called the resin infusion process. A famous one is called script. And that's the Siemens Composites resin infusion molding process. That's a patent back from the 80s that has expired, so everybody can do that now. Okay, and then here's a part being made with script. All right. So that's surface infusion. The resin is running over the surface and goes down into the laminate. Another infusion process is called interlaminar infusion. And here we use the core material or the neutral axis, the center of the laminate, as a way to get the resin distributed. So on the first one, we had a piece of fabric in there that was a flow media fabric, and we had channelways on that fabric. That flow media fabric and the channelways were separated by a peel ply. And when we're done, we're going to peel the peel ply, all those channels, we're going to throw that away. Okay, so it has a lot of waste to it. Interlaminar infusion helps eliminate some of that by letting the laminate take the purpose of the infusion media, so that there's a porous layer in the laminate. So let's say it's a core material, it's got those curved scored cores. That's a pathway that resin can run through to help wet it out under vacuum. Here you'll see a picture of a boat being made, and this is one of our patented process where we use the stringers and feeders and we basically build runners right into the framing system of the boat, and what that allows us to do is inject those under pressure, and then we pull vacuum on it. So this would be one of those Varden processes where now we can apply pressure because we've got that resin sock contained under the stringer. Okay, so whether we've open molded it, closed molded it, now at some point we've got to get the part out of the mold. And this is the time we want to be careful. The part is still green. It hasn't fully cured. Some of these laminates are going to take a month to get to their full properties. Okay, so we don't want to pull the part until it's cooled down. If it's still hot, allow it to cool. All right, and then you want to follow the proper procedure to move that part, because the last thing you want to do is damage the part as soon as it comes out of the mold. For a lot of parts, they're not in their full constructural configuration until you bring all these different parts together, the hull, the deck, all this come together and help form the structure. So while they're partial components, we need to make sure we're supporting them properly and we're not overstressing them. And as we pull these parts, we got to make sure we have the right tools and procedures so we don't damage the part or the mold. Damaging the mold is expensive too. So some molds can have air injector ports. I've seen water ports used, various ways to get the part out of the mold. For routine parts, you have a flange on the tool, and you can use a set of wedges, and you can pop that part out. Most parts aren't terribly hard to make, come out of the mold, but if they're really high geometry or in low draft, you can have some mold challenges. Okay. And like we said, you want to make sure you're not overstressing the parts. And last thing you want to do is you got overhead cranes in these factories, and I've seen it where the part's not coming out of the mold and it's attached to a couple overhead cranes. They're picking up the boat and the mold, and they're using the overhead cranes to bounce it loose on the floor. You know, what do you think that's going to do to your mold life? Okay. So certain parts are more prone to come out of the mold than others, like a flat deck will be prone to pre-release, where Something that has a lot of geometry is going to be much harder. All right. So pre-release, we talked about it maybe a little bit when we were talking about gel coat. That's when the part started coming out of the mold and we haven't finished laminating. So when that happens, it can really be a problem. For a boat, it's severe. If it's the hull bottom, it can cause a hook built into the shape of the hull, and the boat can never perform right potentially. So if you got pre-release, you're going to have to make that tough decision. Do you continue to use the part, or you continue onward? But one thing we don't want you to do is ever try to save a part by screwing it down into a mold. Okay, applying vacuum to the mold to pull the part in, perfectly acceptable. And some boat builders will actually keep a vacuum on the gel coat and the mold during the entire part build to help prevent pre-release. Okay, so we talked about this again, right? Follow that sequence. Make sure you're following the process you're supposed to use. And if you're having trouble getting a part out of the mold, it's really important that you get supervision involved, because molds are very, very expensive. If we damage a mold, it could knock us out of production for some time. Okay, now we've got it out of the mold and we want to trim the part. So we start with cutting tools, and by far the most common method by hand is we have the flange of the tool that acts as a guide. So it forms a natural guide for us. The flange of the tool is a cutaway. We've used that flange to pry the tool out of the mold. Now acts as a guide for a grinder to come and trim the part. Okay. Now, as you get to more higher volume shops, what you're seeing is they're going to pull that part and they're going to mount it onto a jig, and it's going to go into a robot cell, and the robot's going to trim the part. It's not just going to trim the part, it's going to cut every hole out for the part, everything. So that really is nice, but it has a lot of capital investment that you got to have, and you need a lot of volume to really make that work. Okay. So as we're trimming the part, we want to make sure our tools are in good shape. Okay, we've got the right tool, we're running it at the right speed. Okay, this is a dusty operation, so there's grinding dust everywhere. Wearing your proper respirator, personal protection. Some factories actually have very nice air supply suits, so they're sitting there like the Pillsbury Doughboy in an air-conditioned bubble. But you want to make sure you got something, because that dust, you don't want to be breathing it in without protection. All right, great. We've taken you through all of the basics of lamination. With the lab work, this is going to sink in really good, and then the next classes are going to help drive it further. So we hope this has been helpful to you. Thank you for taking the class.